Hello, everyone. This session, we're going to look at the test for problems together. Okay, question 1. We got, what is the domain of g of x equals ln of 4x minus 11? Now, to find the domain of any log function, what we need to do is set the input expression here, the 4x minus 11, and has to be positive, and so we're going to set it greater than 0. So anytime you have an ln here function, you're going to rewrite it, whatever's inside the parentheses, set it greater than or equal to 0, and we're going to solve for x. So we can add 11 here to both sides and get 4x is greater than 11, then divide by 4, and we get x is greater than 11 over 4. So that means on the number line, right, we have 0, 11 over 4. It's going to look like anything that's to the right of 11 over 4 because it's greater than 11 over 4. And as an interval notation, we need to write it as 11 over 4 to infinity. Okay, next, what's the horizontal asymptote of the graph? F of x equals 7x squared plus 2 over x squared plus 2x, and it says to give your answer in the form of y equals a. So to find horizontal asymptotes, we need to compare the degree of the denominator with the degree of the numerator. So here we have the degree of the numerator is 2 and the denominator is 2 because they're both equal. We write y equals and divide the coefficients. The 7 over the coefficient of the denominator is 1. So in this case is y equals 7. Okay. What if, for example, you got a function that looked like this, 7x over x squared. Well, if your degree of the numerator is smaller than your degree of the denominator, the horizontal asymptote would be y equals 0. Okay, so these are just extra examples. Actually, let's say this is a function. What if the degree of the numerator was bigger? Then this would have no horizontal asymptote. But for this example, this question, because they're equal, the degrees are equal, the degree referring to the exponents, the highest exponents. When they're equal, you divide the leading coefficients, and those are the numbers that are in front of the x with the highest exponent. Okay, number 3 says to consider this graph, f of x equals x squared minus x minus 42 over x squared plus 4x minus 21. We need to find the vertical asymptotes. Now, to find the vertical asymptotes, we need to factor, write it in factored forms. So if we factor x squared minus x minus 42, okay, products of negative 42 and sum of the b term, negative 1, are negative 7 and 6. So the numerator factors as x minus 7 and x plus 6. The denominator, we factor x squared plus 4x minus 21. Okay, products of negative 21, that's a sum of 4. It's here 7 and 3 with a negative 3, so we factor this x squared plus 4x minus 21 as x plus 7, x minus 3. The vertical asymptotes we get by setting the denominator, the factors to 0. So since we have 2 of those, we're going to set x plus 7 equal to 0 and x minus 3 equal to 0. And here we subtract 7 and get x equals -7. So there's one vertical asymptote. And here we're going to add 3 to both sides, get x equals 3. So we have vertical asymptotes, and it says don't include x equals, so just type in the vertical asymptotes, -7 and 3. So if you type in x equals, it'll count it incorrect. Okay, number 4, we have let f of x equals 2 to the 3 x minus 2 and evaluate f of 4. We just need to substitute 4 in for x. So we have 2 parentheses 3, 4 minus 2, which is equal to 2, 3 to the second power. We do the exponents first. So 3 to the second is 9. We multiply and get 18. Okay, number 5, David invests $800 into an account with 2.3% interest rate. That's compounded semi-annually. How much money will he have in this account if he keeps it for 5 years? So for this problem, we need the compound interest formula, right? That was A equals P1 plus R over N raised to the NT power, where A was the accumulated amount, and that's what we're trying to find in this problem. We have the principal initial net investment at 800. And then we have R being 2.3%. So we need to write that as a decimal. So 0.023. And then we have the T being 5 years. N is semi-annually, so that's twice a year. So let's plug it in as 800, 1 plus 0.023 over N, which is 2, raised to N times T, so it's 2 times 5. So we're going to plug this into the calculator. Let me switch my... Okay, so here's my graphing calculator, and you can use a scientific calculator. It'll work there too. 800, we have 1 plus 0.023 over 2. And oops, that should be a 3. Just be careful that you're typing it incorrectly. Raised to 2 times 5. And we get 896.91 cents. And it says to round to the nearest dollar. So we got, it was $896.91. Round to the nearest dollar is $897. And number 6, what's the domain and range of the function? F of x equals 7 over 2 base 3 to the x plus 3 power. Domains of all exponential, this is an exponential function. These are variables in the exponent. The domain's easy because domain of all exponential functions are -infinity to infinity. Okay, now for the range. The range of all exponential functions are usually in the form of 0 to infinity, because remember the basic exponential function looks like this, where you have 0 to infinity. This has no vertical shifts, right? We don't have anything that's being subtracted or added to this. So if it's in this form, it does have a horizontal shifts, but horizontal shifts do not impact the range. So the range of this exponential function is 0 to infinity. You can also graph this function to get a look at the domain and the range, and I'll do that here. So if we go to y equals, I can type in see, 7/2. And then we have 3. And we're going to raise this to the x plus 3 power. Okay, so you can see the domain, right? The domain is negative infinity to infinity because it goes from negative infinity towards a positive infinity for all x values. In range, you can see that it goes from 0 and goes all the way to infinity for all the y values. Okay, number 7. Let's graph f of x equals 5 to the x by moving key points. It says you can only graph integer points. So for this, I would use, an xy table. You only really need 2 points. So we could try 0 and 1, and we can do that by plugging in 0. 5 to the 0 power is 1. So my first point, 0, 1, it's already there, so I don't need to move that point. To get my second point, we have f of 1 equals 5 to the first. So this would be 5. And so you would literally move that point 2, 1 to 1, 5. Oops, 1, 5. And you would be able to do it. This is a screenshot, so I can't move this point. So you would just literally move that point. And so then you would get a graph that looks like this. Okay, number 8, another similar problem. Graph the function f of x equals 2 with base 3 to the x by moving key points. And so the same thing, let's see if we use xy table 0, 1. F of 0 is 2 to the 3 to 0 power, and 3 to the 0 power is 1. So we have 2 times 1, which is 2. So there's my first point. And we have f of 1, which is 2 raised to the 3 to the first, is 2 times 3, which is 6. So you need to, again, move these 2 points that are already on there. I'll just use a green to see that, so I can show you the difference here. So my first point should be at 0, 2. And the second one should be at 1, 6. And then your new graph would go through 0, 2 and 1, 6. Okay, number 9, round ln of 53 to the nearest 10th. So for this one, you do need a calculator. And so let me switch to my calculator screen. Okay, all calculators have an ln buttons, but my ln button's right here, and we put 53, and we get 3.97. Okay, so we have 3.97. The tens place, so here's a tens place. So I would round to, because the 7 is bigger than 5, as 4.0. Or I could just simply say 4. Okay, number 10, rewrite log base 4 of 2x plus log base 4 of 6y, excuse me, as a single logarithm. And so for this one, we need to recognize that this is the product rule. When you have an addition here of adding of these 2 logs, we can rewrite this as log base 4 becomes 2x times 6y. And this comes from the rule where if you have log base b of m plus log base b of n, you can condense it and write it as log base b of m times n. And so we have this 2x times 6, 5, so we have log base 4. And I can combine the 2x times 6y, write as 12xy. And so for this, I would write, you would type in the 4 here, And then the 12xy, you would type in that space. Okay, number 11. Use a quotient rule to expand log base of 8y minus 5 over y. We're going to use the quotient rule. And to use a quotient rule to expand with division becomes log base 8 of 8y minus 5 minus log base 8 of y. I guess I could put parentheses around here, and that's it. This is expanded. The quotient rule says if you're dividing, you expand, it becomes subtraction. Okay, number 12, use the power rule to simplify ln of 13 to the 6th power. The power rule says whenever you have a log and you have a power here, you can bring it to the front of the log. And so we can write 6 ln of 13. Okay, number 13, use a change of base formula to express log base 8 of 3 using ln. And so it's when entering the natural log in your answer, enter lowercase ln as just ln. And so for this one, of 3, this can be written as ln of 3 over, or I guess since it's just one number, of ln of 8. And this is true for any of the change of base formula. If you have log base b of x, you can write it as ln of x over ln of b. Or you could also have written this as log base b of x over log base b of I should have used a different base here, but if I could have used a different base, let's call it log of x, base 10. And I could say log b, but because this wants us to use ln, we're going to go with this one and just write ln of 3 over ln of 8. Okay, question 14, use a change of base formula to express log base 5 of 8 using ln. So similar problem. So we have log base 5 of 8. We can express this as ln of 8 over ln of 5. Okay, number 15, what value of x makes the equation 7e raised to the 5x equals 39 true? So actually we need to solve for x here. And we can do that first. Actually, let me write this problem down. We can do that by first, you need to get the b by itself, the base e. We do that by dividing both sides by 7 first. So we have e raised to the 5x equals 39 over 7. To get rid of this base e, we can do ln to both sides. So we do ln of e to 5x, and we have ln of 39 over 7. This simplifies to 5x equals ln of 39 over 7. And then to get x by itself, you can divide both sides by 5. So the answer is x equals ln of 39 over 7 divided by 5, but it wants a decimal answer. So let's go ahead to our calculators and type that in. So we had ln of 39 over 7, close parentheses, and then we divide that by 5 again. So we have 0.34. Let's go back to the main screen. Okay, so it's 0.34, but we need to round to the tens place. So this is 0.3. So be careful with the rounding if it asks you to round to the nearest tenth to make sure you type in 0.3 instead of 0.34. Okay, number 16. Let's solve this equation. 3e to the 2x equals 26. Similar from the last problem, we divide both sides by 3 to cancel that 3 in front of the base e. We have e raised to 2x, and we have 26 over 3. We do ln to both sides. And then, so in case you forgot why ln of e, how that simplifies, using the power rule, right? The 2x would come down, and we would get ln of e. ln of e is 1, because here the base here is e, and e raised to the first power is e, so that would be 2x. So that's why you get 2x when you have ln of e to 2x power. And we have ln of 26 over 3, and finally we divide both sides by 2. We get x is equal to ln of 26 over 3 over 2. And let's go ahead and round this using the calculator again. Ln of 26 over 3, close parentheses, divide that by 2. And we have 1.079. And so 1.079 can round to nearest tenths. And so because 7 is bigger than 5, we round this, oops, I meant 1.1. Okay, just be careful with rounding. Number 17, determine the value of x which satisfies log base 4, 4x plus 32 equals 4. So here we need to rewrite it into exponential form, or you take the base. Okay, let's go over how we do that. If you have log base b of x equals y, you can change it into exponential form by writing base to the exponent equals x. So we write here, that's the base 4, remember that's the exponent raised to the 4th power equals 4x plus 32. If we do 4 to the 4th power, that gives us 256 equals 4x plus 32. Let's subtract 32 on both sides and get 224 equals 4x. Divide by 4 on both sides. And we get x is equal to 56. You can always plug it in by substituting and then checking your answer that way. Okay, number 18, we have 2019, the population was 38,100 with continuous growth rate of approximately 4%. What will be the population in 2044 according to the exponential growth function? So the exponential growth function we're going to use for population is a of t equals p e raised to the RT power. And in this case, the population, the original population is 30,800, 100. We have the annual rate of 4%, so we write it as 0.04. T is the number of years, so for that, we need to subtract 2044 minus 2019, which gives us 25. Okay, so we substitute this in. We have A of 25 equals 38,100 E raised to 0.04 times 25. And we just need to plug it into the calculator and then make sure round it to the nearest whole number. So we got 38,100. My E button is right here. And we type in 0.04 times 25. and get 103,566.5377. Remember, we have to round that. So let me go back to our main page. It says to round to the nearest whole number. And so I need to round it to the ones place. So we have 103,567 people. Okay, number 19, evaluate log base 9 of 9 to the 8th. You can do this using the calculator, or remember that there is an inverse property of logarithms. If you have log base b of b to some power x, this just becomes x. Another way you can also reason this out if we use the property rule and get x to come down. If you have log base b of b, that would just be 1, and x times 1 is just x. So you can kind of think of these as, right, this log base of 9 of 9. Okay, what's remaining would be just 8. Okay, number 20, we have a sample of bacteria decaying according to the exponential decay model. Let's write the exponential decay model being, let's write decay model of d of t equaling some initial value. Should actually, let's just write a some initial value, and we have e to the negative k because it's a decay to t. Okay, if the sample begins with 700 bacteria, so that would be our initial. Okay, 700 bacteria. And after 20 minutes, so that will be our time. There are 420 bacteria. So that would be our A of 20. That would be our the number of bacteria at 20 minutes. And what else do we know? After how many minutes will there be 40 bacteria remaining? Okay, so first we need to find the value of k first. And then we're going to find the t. And when we find k, we need to round to 4 decimal places. So let's first find k. First, we find k by setting what we know into this formula. So a of t, that would be 420. The initial would be 700. We have e negative k to the 20th. Or I could actually rewrite this as negative 20k. Okay, so first we need to find our k value. Okay, we need to divide 700. So this would be, if we put it in the calculator, it would give us 0.6, is e negative 20 k. And then we would take ln of both sides. We have ln both sides, and this would give us ln of 0.6 is negative 20k. Divide both sides by negative 20. And if you put that in the calculator, and I'll just put in the calculator without switching my screen, it would be 0.0, we round it to 4 places, 0.0255. Okay, next we need to find the number of minutes when there's 40 bacteria. So this is part 2 remaining. And so for that, we need to it's like part 2 of the equation where you reset it as 40 equals the initial is 700. And then we have E. We already know the K value would be negative 0.0255. And then T is the unknown. Okay, so that's what you're trying to solve for. Okay, similar fashion as we did in part 1, you have to divide both sides by 700. You get 40 over 70, which if we put it into the calculator, or 700 in a minute. Actually, let me just keep it in that form. I'll put 4 over 70, so I don't have to round at this point, and we have E negative 0.0255t, and then you would do ln of both sides. And then we are left with L, running out of space here, but we are left with ln of 4 over 70 equals E, the E's, the negative 0.0255t. And then in this case, we would divide both sides by t. Running out of space here, so I'm going to write that here. So t would be ln of 4 over 70 divided by negative 0.0255. And if we type that into the calculator, 4 over 70 divided by, don't forget the negative sign, 0.0255. We get 112 minutes, and it says to round to the whole number. We have 112 minutes. All right, I hope this session was helpful. Again, if you have questions at any time, feel free to reach out.